All right, thank you. Well, as a matter of disclosure, I was a member of the systematic review team and have a relationship with ILSI North America, serving as their scientific advisor for the caffeine working group and previously as a consultant for the same group. So for the evaluation of reproductive and developmental outcomes for this systematic review, the components of the PICO research questions differed somewhat from the other outcomes in that we had to consider two populations for comparison to the NAROC conclusions. So while all studies involved adult populations, the majority of studies involved the assessment of caffeine intake in pregnant women, where we applied the corresponding NAROC comparator of less than 300 milligrams of caffeine per day. And for the few studies evaluating non-pregnant women or men, we applied the NAROC comparator of less than 400 milligrams per day for healthy adults. So using the endpoint of fetal growth as one example of our 10 endpoints under consideration, we asked, for example, for healthy pregnant women, is caffeine intake above 300 milligrams per day compared to intakes of 300 milligrams per day or less associated with adverse effects on fetal growth. So a total of 94 full-text papers were evaluated for reproductive and developmental outcomes, and of these, 36 did not meet the criteria for inclusion, and this was primarily due to the absence of quantitative measurements of caffeine intake exposure. So for most studies for this outcome, most studies were observational designs, either cohort or case control studies. However, there were 3 randomized controlled trials. Most studies were specifically designed to evaluate the effects of caffeine, primarily using data collection instruments such as food frequency questionnaires to collect self-reported servings of caffeine-containing beverages such as coffee, tea, and soda. A chocolate intake was considered in a few studies, as well as caffeine-containing medications and energy drinks, but in far fewer. Number of reported servings were converted to milligrams of caffeine consumed per day, either by the author or by the research team. Caffeine intake was commonly grouped into categories, so most studies reported findings for defined ranges of daily intake. Most of the caffeine exposures assessed in these studies were either at or below the 300 milligram per day comparator for pregnant women. So in fact, only about 1/3 assessed caffeine intake levels that exceeded the 300 milligram per day comparator, with the highest value assessed being greater than 1,000 milligrams per day. So the 10 endpoints examined included measures of fecundability and infertility, spontaneous abortion, recurrent miscarriage, stillbirth, preterm birth, fetal growth, birth defects, childhood behavior, and childhood cancers. And then we also had another category which included 2 single studies that addressed pregnancy-induced hypertension and preeclampsia and markers of maternal stress. So as I highlight the results reported for the selected endpoints, I'll begin here with endpoints for fecundity and fertility, which evaluated the healthy non-pregnant adults using the NAROC comparator of 400 milligrams per day. So this plot provides, as you heard before, a visual display of the selected results reflecting the lowest observed levels in orange and the no effect levels in blue. Of the studies meeting the inclusion criteria for this endpoint, 2 examined time to pregnancy, 4 evaluated male reproductive parameters, and 2 examined other fertility endpoints, including ovulatory infertility as well as age at menopause. So overall, the findings were generally consistent, indicating the lack of effects below or above the 400 milligram per day comparator. And this consistency, along with the overall evaluation of low risk of bias, resulted in a moderate or high level of confidence in these endpoints. Among studies of spontaneous abortion, there were a few data points that indicated observed effects at levels below the 300 milligram per day comparator, although these were limited to 2 studies where one reported observed effects only among some subpopulations with certain phenotypes for caffeine metabolism. But at the other end of the spectrum, there were also studies reporting lack of effects following consumption as high as greater than 500 milligrams per day. So confidence in the overall body of evidence for spontaneous abortion is decreased by this lack of consistency in the direction of findings, both above and below the comparator. So confidence in this evidence is further limited by the inability to account for confounding by the pregnancy signal, which is a critical concern that I'll address further as I discuss evaluation of study quality. So considering the totality of the evidence, there was a moderate level of confidence in the body of evidence that the comparator of 300 milligrams per day is acceptable as an intake that would not be associated with significant concern for spontaneous abortion. Studies of gestational age and preterm birth were considered together for the purpose of this systematic review. And of the 5 studies identified for this endpoint, no associations with preterm birth and maternal caffeine consumption were reported at any intake levels at or above the comparator. So this consistency leads to moderate to high levels of confidence in the body of evidence that the comparator of 300 milligrams per day in pregnant women is an acceptable level. The body of evidence for fetal growth was more difficult to integrate based on inconsistent findings. So of the 14 studies that evaluated endpoints such as birth weight, small for gestational age, and intrauterine growth restriction, 9 reported no observed effects with maternal caffeine consumption below the comparator of 300 milligrams per day, while the remaining 5 studies reported adverse effects on fetal growth at intake levels below the comparator. So refined conclusions were more challenging for fetal growth, given that all comparison points below the comparator indicated observed effects, suggesting the comparator may be too high, whereas the majority of the comparison points at or above the comparator reported lack of effects, suggesting the comparator may be acceptable or too low. Ultimately, the biological significance of changes in birth weight were considered to be more robustly evaluated in studies evaluating small for gestational age or intrauterine growth restriction, which as a whole did not provide support for effects below the comparator. So across all studies, confidence in the body of evidence was deemed to be moderate to high, that intake below the comparator of 300 milligrams per day is acceptable, as an acceptable level that's not associated with significant concern for adverse effects on fetal growth, including endpoints of small for gestational age and intrauterine growth restriction. For birth defects, the evidence is quite broad, with many types of birth defects evaluated across 11 studies, with few studies reporting results for any single type of malformation. The majority of the data for birth defects was relatively consistent in demonstrating a lack of effects following consumption of caffeine at intakes up to 300 milligrams per day. Of the 3 studies reporting effects below the comparator, none observed a dose response, and these case-control study designs were susceptible to recall bias. So we concluded that with a moderate level of confidence that 300 milligrams per day is acceptable as an intake that would not be associated with significant concern for birth defects. So as the spectrum of study results were considered in relation to the comparator, as you have heard described before, each individual study was evaluated for study quality according to the 10 domains specified in the OHAT risk of bias tool. And so this graphic is providing the snapshot of that risk of bias heat map. So across all domains, studies of reproduction and development were determined to have an overall low risk of bias, as demonstrated by the majority of the green shading in the heat map, and few studies fell on either end of the spectrum. But in general, when studies were downgraded into either the pink or the red categories for probable or definite high risk of bias, it was commonly the result of 2 primary study design limitations. The first relates to methods that are used to address confounding by the pregnancy signal. And this is primarily recognized as a concern for spontaneous abortion, but it also applies to studies of other endpoints, including preterm delivery and fetal growth. So this phenomenon of the pregnancy signal relates to research that's shown that pregnancy symptoms such as nausea and vomiting and aversions to tastes and smells are associated with favorable outcomes and reduced risk of pregnancy loss. The specific mechanism for this association, it's not well understood, but it's proposed to be associated with increasing levels of either pregnancy hormones or human chorionic gonadotropin, which are produced at increasing levels by a well-developing pregnancy. So these women who experience pregnancy symptoms have also been shown to reduce their caffeine intake in response to the aversions to strong smells and tastes, such as coffee. So women who do not have healthy developing pregnancies may continue consuming coffee or caffeine at higher levels because they're not experiencing the same symptoms. So when these groups are compared without accounting for confounding by the pregnancy signal, then it could appear that those with higher caffeine consumption are at an increased risk of adverse pregnancy outcomes, when in fact intake levels are actually a consequence of an unhealthy pregnancy. So although most studies of spontaneous abortion did attempt to take pregnancy symptoms into account, typically this was measured as either a presence or absence of nausea or perhaps frequency of nausea. And this may not provide a valid assessment of the relevant aspects of the pregnancy signal, such as aversions to taste and smells that may be more directly influencing caffeine consumption patterns as a consequence of the health status of the pregnancy. And because of these known complexities, then these studies were assigned a rating of probably high risk of bias for the confounding domain of evaluation. And others that did not attempt to address the pregnancy signal were scored as high risk of bias for this element. In addition, study ratings were also uniformly impacted by the known difficulties of accurate caffeine exposure assessment, which is reflected by the red column to the far right. It's certainly well appreciated. The reporting, general concerns about reporting errors are generally appreciated for observational studies, but specifically for studies of pregnancy outcomes, there's also concern regarding the timing of exposure assessment and the ability to capture changing patterns of intake throughout pregnancy. So overall, these challenges lead to uncertainties in exposure assessment that can limit the evidence base. So for each endpoint assessed, we also went through a systematic process to qualitatively evaluate the confidence in the body of evidence. And for the 7 endpoints that had a sufficient number of studies to draw conclusions, and we define that as 5 or more studies, we developed initially moderate confidence ratings based on the basic elements of the study design, and then using the expert judgment, increased or decreased or did not change that level of confidence for each endpoint based on a number of factors. So as reflected by the upward arrows in the 4th and 5th columns, the general evaluation of low risk of bias and low indirectness, which reflects generalizability or external validity, this increased our confidence in the body of evidence for most endpoints. When we considered the remaining factors, the difficulty of accounting for confounding by the pregnancy signal and the moderate magnitude of effects that were observed below the comparator decreased confidence in studies for spontaneous abortion and fetal growth. On the other hand, the consistency of results increased our confidence in the body of evidence for fertility and fecundability, recurrent miscarriage, preterm birth, and birth defects. So in total, our overall confidence in the body of evidence ranged from moderate to high for this outcome. So the purpose of then displaying this graphic is not to review the many details, but to highlight the process that the review team used to integrate the weight of the evidence and establish our conclusions. So ultimately, our conclusions were informed by the synthesis of the body of evidence, which considered the spectrum and the volume of data both above and below the comparator, as well as the evaluation of the quality of the evidence. And so when we considered the range of effects, there was substantial overlap within the body of evidence for the reported ranges of both no observed effect levels and low observed effect levels. And this was the case for all endpoints examined, except preterm birth and child behavior. And these were effects with these are outcomes where no effects were observed at any level examined. So if you focus on the area with the green shading in the middle of the table, the X's indicate that for most endpoints, the findings were reported across the entire spectrum of results, with at least one result in each category reflecting that the comparator was either acceptable, too high, or possibly too low. So considering the totality of the evidence, the green shading represents that the conclusion for each endpoint relative to the comparator was overlapping across the different outcomes, and this corresponds with the conclusion that caffeine intake at levels below the comparator is acceptable for all endpoints examined. Note, however, that for certain endpoints, uncertainties are acknowledged by the shift in either direction. So for preterm delivery, we acknowledge the possibility that the comparator may be too high given the consistent reports of no observed effect levels at or above 300 milligrams per day. In contrast, for spontaneous abortion, we acknowledge that the comparator may be too low for certain subpopulations where effects were observed below the comparator for some metabolic phenotypes. And for fetal growth, effects on birth weight were also reported at intakes below the comparator, suggesting the comparator may be too low. But our conclusions were based on the biological significance of such an effect, which is more robustly evaluated in studies of small for gestational age, which as a whole did not show effects below the comparator. So when the weight of evidence was considered for pregnant women, we concluded that an intake of 300 milligrams per day was generally without significant concern regarding overt adverse effects on reproduction and development. The majority of studies included in this systematic review do not report reproductive or developmental effects at intake levels below the comparator for healthy pregnant women, but effects below the comparator cannot be ruled out with the currently available data. For some endpoints, including fetal growth and spontaneous abortion, evidence indicated that intakes at the level of the comparator could possibly be high for some subgroups. However, uncertainties in the evidence base were encountered, and as mentioned, these included the consideration for the biological relevance of changes in birth weight, as well as limitations of the methods used to control for the pregnancy signal. So overall, we had a moderate level of confidence in the evidence base for the conclusions for pregnant women. When the weight of evidence was considered for healthy adults, an intake of 400 milligrams per day is generally without significant concern regarding overt adverse effects on fecundability and infertility as measured by time to pregnancy, male reproductive parameters, ovulatory infertility, and age at menopause. And there was a moderate to high level of confidence in this evidence base. So overall, the current body of evidence for reproductive and developmental endpoints is generally consistent with what was reported by NAROT and other reviews of caffeine and reproductive and developmental outcomes. And as such, the current guidance for pregnant women is supported by the findings of this systematic review. So for future research considerations, we conclude that further evaluation of potential effects of maternal caffeine intake on childhood cancer is warranted due to the limited number of existing studies with inconsistent results and concerns for potential recall bias. Because there were only 3 studies on childhood cancer, a conclusion for this endpoint was not developed in this systematic review. Future efforts to disentangle the complex relationship between pregnancy symptoms and changes in caffeine intake during pregnancy and pregnancy viability will benefit from improved prospective assessment of all relevant dimensions of the pregnancy signal, including aversions to caffeine-containing products. Studies are also needed to clarify the importance of the pregnancy signal for all relevant endpoints, for fetal loss as well as outcomes regarding fetal growth and congenital malformations. Since some studies have suggested that some subgroups exhibiting differences in caffeine metabolism may be more susceptible to the adverse reproductive health effects of caffeine, then this is also an area that warrants further research. And then finally, we have the ongoing challenge for observational studies of caffeine with regard to accurate measurement of exposure. And so studies should continue to optimize exposure assessment with attention to capturing the changing patterns of intake that occurs during pregnancy. Thank you.